Okay, so let's have a look here. A particle moves in a straight line with simple harmonic motion about point O as its center. Its displacement O at any time at time t is x. At time 0, the particle passes through h a distance 3 from the origin, moving away from the origin. The particle then next passes through h 4 seconds, and then moving towards the origin this time, and then it passes through h for a third time after 12 seconds. So if I was to graph its position, x and time, it begins 3 centimeters away from the origin, and then it's traveling further away, so it increases up to the amplitude, and then comes back down, and it's at the 3 centimeters again, and I feel like that should be symmetric. So this time here is 4, so it makes me feel like that is 2, and then it heads towards the origin, reaches the origin. But I suppose the only problem is point H is only on one side, so it reaches on the other side 3 centimeters away, comes back, and then now we're back at the original one. That's after a further 12 seconds, so that would be at 16 seconds. I feel like this should be in the middle at 10 seconds. That will go back up 18 seconds, because it's the same as what we had at the beginning. So I think a period would be from 2 to 18, so that's 16 seconds. I'm saying it's the periodic time, I'm hoping, is 16 seconds. Show that that formula satisfies that equation, though that's fine. You can calculate the first derivative, and that would be a omega cos omega t plus epsilon. Then calculate the second derivative, which will be minus a omega squared sine omega t plus epsilon. And then note that minus omega squared x would equal minus omega squared a sine omega t plus epsilon. And you can note clearly now that the second derivative of x is the same as minus omega squared x. So that's all fine. And then we want to find the values of a, omega, and epsilon for the particle. Well, we know the epsilon, the omega is 2 pi over the t, and we've worked out the t, so that's 2 pi over 16. So that's pi over 8, so that's great. The amplitude we have not worked out, but we know it's more than 3, and the epsilon we've not worked out either. So if we sub in our values, x3, I'm going to use meters, 0.03, that's x equals a sine epsilon. That's the first value here. Let's look at the second one. The amplitude, that's equal to a sine 2 omega t. We're subbing in t is 2. We're looking at this point here. So that would be pi over 4 plus epsilon omega t plus epsilon. So that means that pi over 4 plus epsilon has to equal 90 degrees, pi over 2. So that means epsilon is pi over 4. So I have the epsilon and I have the omega. So all that's left now is to get the amplitude. Oh yeah, and just put it back in here. So then I get the amplitude is 0.03 over sine pi over 4. So that's 0.03 sine pi over 4. That's 1 over root 2. So it's going to be 0.03 times root 2. I don't think there's anything nice we can do with that. And maybe I should stick it back to centimetres since the question gave it in centimetres. Let's have a look here. About 4 centimetres, roughly. 4.24 centimetres is the amplitude. Okay, hopefully that's okay. I got the period. I think I've shown the equation is true, bit of calculus, chain rule, and I think I have the A omega. Well, you know what? Actually, there is a way we can check. 4.24 times sine omega pi over 8 multiplied by the t plus the epsilon. Okay, so let's check. If I put in t as 0, I get 2.998. Yeah, so I get 3 centimeters. Okay, and then if I put in t as 4, I get 2.998. Yeah, great. And then if I put in 16, I get 2.998, yeah. And actually, I don't really like the decimal here. I always prefer to keep it in Cert form if I can. So rather than leaving it like that, I'll just keep it in the form of 3 root 2, like I said a moment ago, rather than the decimal of 4.24. Okay, I think that's good.